Most SAT math questions repeat the same patterns. In this video, we'll solve a full Module 1 and focus on the fastest ways to recognize them and save time. Let's jump right in, starting with a straightforward graph question. We're given a line graph showing the percentage of cars for sale by model year. The question asks, for which model year is the percentage smallest? That means we're looking for the lowest point on the graph. Check the graph. The lowest dip happens at 2014. Next up, a system of equations on a graph. This is a classic intersection point question. We're shown two lines on a graph, and we need the solution to the system. Remember, the solution is where the two lines cross. Looking at the graph, they intersect at 4 and -5. Got it. Now, a classic SAT question. Modeling cost. We have a $25 service fee plus $10 per hour. Renter wants to spend at most $75. Let it be hours rented. Total cost equals 25 plus 10 times t. We want that to be less than or equal to 75. That matches choice D. Done. Next question, graph translation. Don't let it trick you. This tests your understanding of graph transformations. We're told the graph is translated up 4 units. That means every y value increases by 4. The original graph passes through points like 1, -1, 2, -2, 3, -1. Add 4 to each y, only choice A matches that. So remember, we're translating the graph upward. That means only the y values change. The x values stay exactly where they are, but we add 4 to every y coordinate. Moving on to the speed equation. Direct substitution problem. We're given s equals 40 plus 3t, where s is speed in miles per hour, t is seconds. Find speed at t equals 5 seconds. Plug in. S equals 40 plus 3 times 5 equals 40 plus 15 equals 55. Got the speed. All right, before we move on, if this walkthrough is helping, feel free to subscribe for the next module. Let's go to the next question. Now, let's find the value of a function. Another quick plug-in question. Given f of x equals x squared plus x plus 71, we want f of 2. F of 2 equals 2 squared plus 2 plus 71 equals 77. Great, got 77. Now let's jump into a real-world budgeting problem. You'll see this type all the time on the SAT. Party planning on a budget. Venue fee, $35. Cost per attendee, $10.25. Budget, $300. Start with the inequality. 35 plus 10.25x is less than or equal to 300. Subtract 35 from both sides, and we get 10.25x is less than or equal to 265. Now divide both sides by 10.25. That gives us x is less than or equal to about 25.85. Since we can't have a fraction of a person, we round down to the nearest whole number. So the maximum number of attendees is 25. Nice! So 25 attendees is the max. Next up, probability from a table. This one's quick if you know where to look. We want the probability that a randomly chosen student voted for Lion. From the table, Lion votes equals 20, total votes equals 80, so 20 over 80 equals 1/4. That's choice C. Perfect. That was straightforward. Now we're moving into some geometry. Don't worry, it's just about knowing one basic rule. Triangles ABC and DEF are congruent, with right angles at B and E, and angle A equals 18 degrees. Since the triangles are congruent, corresponding angles are equal. Angle C corresponds to angle F. In triangle ABC, 18 degrees plus 90 degrees plus angle C equals 180 degrees. So angle C equals 72 degrees, and so angle F equals 72 degrees. Answer is 72 degrees, choice B. Geometry done, see? Not so scary. Up next, a clever algebra shortcut that'll save you a ton of time. We're given 4x plus 2 equals 12 and asked for 16x plus 8. Notice, 16x plus 8 equals 4 times 4x plus 2. So 4 times 12 equals 48. That's 48. Choice B. Smart multiplying, love that trick. Okay, quick pause. If this is helping, please like the video. Let's continue. Now on to exponent rules. Combine, don't overcomplicate. Multiply coefficients. None here, so just combine like bases. M to the power of 4 plus 1 equals M to the power of 5. q to the power of 4 plus 5 equals q to the power of 9z to the power of minus 1 plus 3 equals z to the power of 2. Choice B. Exponents handled. Next, what type of function best models an airplane descending at a constant rate? Constant rate of change implies linear. Altitude is decreasing implies decreasing linear. That's choice B. Linear it is. Now, a system of equations. 2 variables, 2 equations. Let's solve for y. We have equation 1, 3x plus 6 equals 4y. Equation 2, 3x plus 4 equals 2y. Subtract equation 2 from equation 1. That gives us 2 equals 2y. So y equals 1. Got it. Y equals 1. Moving on. Function translation. If we shift the graph up, what happens to the output? Translating up 4 means g of x equals f of x plus 4. We want g of 0. First, find f of 0. 0 minus 6 times 0 minus 2 times 0 plus 6. That's negative 6 times negative 2 times 6, which equals 72. So g of 0 equals 72 plus 4, which is 76. Answer, 76. Translation complete. Now, let's interpret a function in context. What does f of 14 really mean? We're given f of w equals 6w squared. This represents the area of a rectangle where the width is w and the length is 6w. So f of 14 equals 1,176. That means if the width is 14 feet, the area is 1,176 square feet. That's choice A. Context is key. Next up, exponential growth. Bacteria doubling every day. Classic SAT pattern. We start with 44,000 bacteria. They double each day, so the multiplier is 2. After t days, the equation is y equals 44,000 times 2 to the power of t. That's choice D. Exponential formula set. Now, let's find the equation that matches a table of values. We're given a table showing x in years and h of x is the pole vault height. When x equals 0, h of 0 equals 1.23. That's our initial value. From x equals 0 to x equals 2, the height increases from 1.23 to 1.54. That indicates exponential growth. The only option with an initial value of 1.23. And exponential growth is h of x equals 1.23 times 1.12 to the power of x. That's choice D. Equation matched. Now intercepts. We're finding a plus b where a is the x-intercept and b is the y-intercept. Given h of x equals 4x plus 28. For the x-intercept, set y equal to 0. 0 equals 4x plus 28. Solving gives x equals negative 7, so a equals negative 7. For the y-intercept, set x equal to 0. Y equals 28, so b equals 28. Add them together. Negative 7 plus 28 equals 21. That's choice A. Intercepts found? Nice. Next, which table satisfies the inequality? Let's test each row. First, we check the table against the inequality. For x equals 3, y must be less than 21. For x equals 5, y must be less than 31. For x equals 7, y must be less than 41. Only choice A satisfies all 3 conditions. Table checked. Now another system of equations, but this time we want x minus y. 2 steps. We're given y equals 4x plus 1, and 4y equals 15x minus 8. Substitute the first equation into the second. That gives 16x plus 4 equals 15x minus 8. Solve for x. X equals negative 12. Now plug back to find y equals 4 times negative 12 plus 1. That's negative 48 plus 1, which is negative 47. Now find x minus y. Negative 12 minus negative 47 equals 35. Answer 35. System solved. Moving to geometry. Pythagorean theorem with a twist. Hypotenuse in radical form. The legs are 24 centimeters and 21 centimeters. H squared equals 24 squared plus 21 squared. That's 576 plus 441, which equals 1017. So h equals the square root of 1017. Rewrite that as the square root of 9 times 113. That simplifies to 3 square root 113. So the value asked for is 113. Radical form, done. Now, scale models. Remember, area scales with the square of the length factor. The actual area is 600 square meters. The length scale factor is 1/10. So the area scale factor is 1/10 squared, which is 1 over 100. The model's area is 600 divided by 100, which equals 6 square meters. That's choice A. Next, circle geometry. Which circle touches the y-axis exactly once? A circle touches the y-axis exactly once if the distance from center to y-axis equals radius, and center x-coordinate greater than 0. Equation form, x minus h squared plus y minus k squared equals r squared, with h equals r. Check options only. X minus 4 squared plus y minus 9 squared equals 16 has h equals 4 and r equals 4. That's choice C. Circle condition, clear. Now, triangle congruence. What extra information is enough to prove it? We already know angles B equals E and C equals F, so triangles are similar. To prove congruence, we need one corresponding side equal. So knowing BC equals EF is enough. That's choice C. Congruence sorted. Now, percent increase. If x increases by 1800%, what was x originally? An increase of 1800% means multiply by 1 plus 18. That gives a factor of 19. So we have 19x equals 684. Divide both sides by 19, x equals 36. That's choice D. Percent change, handled. Last word problem, a piecewise cost function. Let's build the equation. The first 2 hours cost $220. Each additional hour costs some rate r. The total cost for 5 hours is $400. So 220 plus r times 5 minus 2 equals 400. That simplifies to 220 plus 3 times r equals 400. Subtract 220 from both sides. 3r equals 180. Divide by 3, r equals 60. So the function is f of x equals 220 plus 60 times x minus 2. That simplifies to f of x equals 60x plus 100. That's choice A. Cost function built. Final question, quadratic equation. Find the sum of the solutions without fully solving. Expand both sides. X squared plus x minus 56 equals 4. X squared minus 28x. The sum of the solutions is negative b over a. That gives 29 over 3. And that's a wrap on Module 1. We covered algebra, geometry, word problems, and data analysis, all in 27 questions. If this felt manageable, you're on the right track. More practice coming next.